Hello, everyone. So welcome to our session here at stage 4. I hope you had a good lunchtime and you are full of motivation to start the second half of the Global Azure Austria. The session is about Microsoft Cognitive Search. Specifically, we want to show you and demonstrate you how you can apply custom skills to the AI pipeline and what are business use cases why you need to do so actually. So we have some references here from Henrichments. But first, let me introduce myself first. My name is Bernd. I'm located in Linz. I'm working as a solution architect at Enrichments Group. But I also have Peter with me. Peter, would you like to introduce yourself?
Hello, my name is Peter. I'm an enterprise architect at Azure. Azure is a Microsoft Gold partner, and we are working on different Azure technologies for quite a long time, but also for Microsoft 365. And Azure Search is one of our hottest topics in the last few years, especially with the AI, in combination with AI, it's getting really very interesting.
All right, thank you. So let's move on. I am going to share my screen, so I guess you can see. So this is something we can just skip because we just did an introduction. Let me show you what you can expect from this session briefly. So we will start with basically the big picture, our motivation, why actually we started to dig into cognitive search as a platform, and also what were our targets here from Androids, what we want to reach out, basically. Then going over to a general introduction to the cognitive search pipeline, we will see there why cognitive search is an appropriate tool to reach our targets. And then we have basically 2 examples prepared representing how you can extract entities from your information. On the one hand, documents. This will be just a brief overview. But in chapter 4, we have something interesting for you, which is about extracting entities and intent from knowledge sources. So we have something prepared that we would like to show you, and I hope this will be interesting for you. We also have some lessons learned to share, which we are happy to share with you at the end of the session. All right, let's start with the first point. Why did we start digging into Azure Cognitive Search? If you have, if you look at evaluated chain processes, common evaluated chain processes, you usually end up in having a quite wide range of line of business applications supporting all these different processes, from sales to project engineering, design, but also installation, quality management, whatever processes are out there. And in big enterprises like Energies, you cannot really avoid that you have a wide range of applications supporting one or multiple processes. And that basically leads to the fact that you have a lot of different repositories hosting your content, your business information, right? This can be in a structured way, databases, but also there is a lot of content in an unstructured way, unstructured format, documents, wiki systems, whatever is out there. And some time ago, we basically wanted to do 2 things. On the one hand, we want to improve the finding experience, typical search use case, by just indexing the content from multiple repositories, merge it to one or multiple indexes, and make it available to users, right? And the other thing is, which is something I will go into detail in the next slide, we actually not want just to index the content, but also want to understand it, extract it, and understand semantically. We want to understand the information in context to our business activity, which basically means thinking in projects, in customer records, in installed base, in machinery, bill of material, and all that stuff. So we want to not just have it as a plain text in an index. We want to identify that relevant information. We want to understand it and bring it in context to our business activity. What does that mean exactly? So due to the regular business, you basically end up in having your major enterprise entities. We call it entities. So it's basically things which define a certain object. Customer, we think in projects, we think in customers, we also think in machines and installed base, which is on customer side, but we also think in transmittals. So package of documents we officially submit to a customer, for instance. And all that information is, as I've explained before, usually spread across multiple sources. But we want to get this out of the different sources and transform it into one information graph, which basically holds all the relevant information. And what do we have to do for that is basically we need to identify the enterprise entities. Projects, how you describe a project, how you describe a customer, these patterns are usually different across companies. So you will not find most probably an skill or a model which is able to identify Android's projects by a project code or project number, because we have a specific schema which describes a project number, for instance. So we want to first identify that from structured as well as unstructured repositories or data, extract the entities, and enrich the information graph. This is, so to speak, the technical target we want to reach. But actually, why do we need that? So on the one hand, of course, we want to have one wrapper which holds all the information. But we want to follow, or we are actually hunting multiple use cases. So I will start with the second one, because this relates now to this enterprise or information graph. So what we want to do is we want to create this information graph having all this business relevant context information, projects, customers, and so on, to be a point of origin, for APIs of the organization or other applications, a kind of mother of all information. Why? We have also a specific example. If you go for customer communication, we are planning a customer portal where we want to build up different use cases. So a use case could be for an authenticated customer user, get all relevant machine documents for the equipment we have delivered in project X, right, for that specific customer. And this is something we would basically not find by having just sending one API call and get the information back. So we need some authority, some instance knowing that information. And this is something where we want to build up an information graph to avoid asking 5 different content repositories. The other one, of course, is obvious. So we want to index the data to have an improved finding experience. And the third one, which is also a very, I would say, a high and maybe difficult to achieve target, but we will show you later on what steps we could go already there. We want to speak with the customer in a way we would do as a person, right? So we need to enable our applications, that can be bots or something else, to interact with the customer in a conversational language, like we would do it between human beings. And that means we need to understand and not just index, we need to understand the content in a way that we can use it for natural language conversation. And this is a very interesting point. And for all these 3 use cases, we started to deep dive and investigate the potential of cognitive search. And we did find the whole ecosystem as a proper way to go forward and meet these targets. what we already learned, and maybe you have seen or you have learned in what I've said before, it's all about entities. So if you go this path, you need to be able to understand your enterprise-specific objects, entities, and this is rather difficult, to be honest. And we would like to share the knowledge we gained, how this could work for different use cases. At this time, I would like to ask Peter if you have additional comments so far.
So far, nothing. Thank you.
Okay, great. Then let's move on. So as I said, we found out that cognitive search and its AI pipeline is an appropriate tool to meet these targets. Why? Or what is our knowledge on this and our things we can share? So basically, the architecture, the whole architecture of Azure Cognitive Search is not really different than, I would say, from others. It's, on the one hand, you have the content, you have certain indexing engines to get the index. On the other hand, you have query languages, APIs, or whatever to enable other clients to get this information. The big thing is, or the big topic was for us, the AI enrichment. So Azure Cognitive Search enables you to inject so-called AI enrichments, which is basically AI skills you can use to get more out of the data. And as you can see below, there are 3 different types actually you can utilize. There is built-in static enrichment. So these are the ones which are provided by Microsoft, like an entity recognition system which is able to understand that if there is Bernd Schickerbauer somewhere in the text, it's able to understand this must be a person to 90% confidence, right? You can also use pre-trained AI enrichments. And for us, the big question was, so how far can we go with pre-trained or static models? And where do we have to run our own custom-trained AI enrichments? I can tell you basically, you can utilize the built-in ones, but you basically rather soon end up in running your own trained artificial intelligence models or deep learning models, which you just inject. And this is the cool thing about the cognitive search into this whole pipeline.
So maybe just one word here regarding the pipeline. We did a lot of working on the pipeline, which means what recognition is done in what order to understand the content that comes into the index. And there are a lot of pre-trained AI enrichments from Microsoft, for example, things like a pre-trained entity recognition, which is able to recognize a city or a date or a person. But the training set of these AI trained enrichments were mostly based on public available information, for example, Wikipedia or something similar. So it's great to use it for consumer applications. For example, if you have a hotel feedback application classification, where you want to automatically classify the feedback that the guest gives you on Facebook or something. But it's not very useful if you have specific entities in your enterprise. So, for example, if you have specific project numbers, or if you have specific document types or something like that. And this is where the custom trained AI enrichment come into play. And it was really a totally shift in the approach using our own models, because we have to invest first before we enrich the documents. We have to train everything that's content in our company. So this is the big thing. If you have a look on Azure Search, you will find there are a lot of pre-trained AI skills. For example, also language translation. It's a great pre-trained skill. You can use it everywhere, because translation is something which is very general. But as soon as it comes very specific for your company, it's hard to get the information out of the pre-trained AI skills.
All right. Do you like to move on here? Peter?
Okay, sorry.
Do you want to? Yeah, I can also. Go ahead, please.
This is the way how the Azure Cognitive Search is working. So it starts from the left to the right. We have a data source where all our documents or database records are located. And the first thing is that we have an indexer which cracks our document, meaning that the document is transformed in a pure text form. So after we have the document content in a standardized text form, the skill set starts to work on this text. And now the skill set can be defined by the developer of the cognitive search. So you can combine any type of skills in that skill pipeline. And normally you're doing things like extracting the language, that you know what language the document is of. In the second one is mostly that you translate it in a standard language. This is very useful if you want to have a search which is possible to be operated in different languages. And then it comes into extracting the entities of a document, and this is where Microsoft offers you different skills which can be used, for example, in a static recognition, for example, looking for some static content in the text of the cracked document, or it can be more dynamic, where the AI skills come into play, where AI models are asked to interpret the content of the document. And the outcome of this skill set is an enriched document, meaning that you do not have only the text of the document included, but you also have some extracted information like metadata. And the metadata can be, for example, the language, then extracted project numbers, extracted persons, extracted all the entities that we defined we want to extract from the document. And the good thing is, it's not only possible to store this metadata in a search index. This is very useful if you want to have a search application. But it also can put the metadata into they call it knowledge store, where you can it's something like a big database where the references to the document, which was the source of the metadata, and the metadata itself is stored. And you can use this then for a lot of different applications like machine learning, analytics, validation, building something like a graph where you can navigate through. So the use cases are really very, very huge for if you do not want to have a search only approach on that. So this is the basic idea. And the information graph it can be used, for example, in Power BI. So you can use any BI tool or custom application to visualize the information of the knowledge store. Bernd, you are on mute. You are muted.
I'm sorry. And as you said, thank you, Peter. As you said, getting the project number out of a document sometimes easier, sometimes less easier. And this brings me to the next topic, that we basically have prepared now 2 examples to run custom skills in the whole skill set. One is a rather static one, and one which is a bit more effort, where you really have to train a model. But on the other hand, you will have a kind of a prediction, and you're more resilient to new values. So I will give you a brief overview on the first example we did. We have shared this already in a session I think in April or March in the Austrian Developer Community Day. So kindly have a look there as well on the video and the recording. So as you said, Peter, the use case was here getting the project number and the customer basically out of documents, and not just new documents. It's basically a range of historic project documentation we had, mainly in PDF and in MS Word. We had different languages, but the focus was how can we just not index the information, but again, thinking on the graph and the projections, how can we identify and grab our main entities we think as an Android organization out of the document. In this case, we basically focused on two properties, which is customer and project name. This is an example for where we basically utilized another tool from Azure, which is the form recognizer. There you can do rather static things based on layouts. So if you see that you share the same layout across years for a specific document, in that case a technical report, you can easily utilize that to get out that information you're looking for. You can either again train your own model to have a certain resilience, or you can refer to specific areas in the document. The outcome is basically a key value pair you can easily get with API. Again, attach it as a custom skill in the search, and you have the first piece of your information graph out rather than having the index. You also have, exactly this document, this technical report refers to project XY in 1994 for customer so-and-so. And this is how you can really get out the most relevant information from all the content you have in your organization. Of course, it's recommended if you can look up related entities already in qualified enterprise information, as the patterns vary across all the organizations. So this is an example. I would say it's not true artificial intelligence, but it's a pre-trained model you can again use as a baseline for your own trained models to grab and identify entities based on your organization-specific documentation. It's
AI, but it's a very easy AI, because it mostly looks just on the position where the project number is normally located. So we have to train the document. We have to train the forms, but it's not fully free form. So it needs to have the project number or project code on a specific position, and the AI is used to be a little bit more fussy in the recognition of that.
Right. So basically, you're relying on a static, more or less static position on a document. That's what it is, right, Peter? Okay. So I would just encourage you for this session. So due to the time constraint, we cannot go into full details for this use case, but it's I would say a quick win. So I really encourage you to check out the session, which is on YouTube. So please go there and check it out. It's really interesting to quickly get your information out of the documents. All right, so this was one example. The other one is a bit more interesting, I would say. Peter, would you like to move on here?
Yes. The other one is a little bit more generic. I think it's sometimes it's not less interesting, the forms recognition, because it has a very high value, but it's not so sophisticated to train it, and you do not have to be so controlled in the training of the model. So can you move to the next page, please? Yeah, this is what Microsoft offers us as a custom skill. Called a custom name entity recognition. It's currently in preview in the Azure language recognition part. So if you go to language.azure.microsoft.com, I think you will see the URL afterwards in the demo. You will see it in action. So what we are doing here is this is the development life cycle of such a custom named entity recognition model, which is the intelligence of the recognition we are using then afterwards in the search. So the first thing is you have to define a schema. The schema defines what kind of entities you want to extract from your data. This can be, for example, project, or it can be a name, or it can be a product, or it can be what kind of entity did we use in the project? I just forget it. I think it was. Let me look.
So yeah, in this use case, we basically will focus on the communication between IT and end users.
Yeah.
So IT usually has IT knowledge. You wanna communicate as best as you can to your end users and answer the question. So we think here in IT services and IT products, and this is something you wanna identify to best serve the customer request.
Yeah. And the first thing what we have to do, we have to take, like in all AI models, we have to train the model. That meaning that we're taking a lot of documents and tagging the documents with the information that we know. For example, we go into every document and we tag all the IT services which are in the document. I will show this afterwards. After we did this with a few documents, we can start the training of the document. And then we go into, we evaluate the details of the models. How do we do that? Normally we're using 80% of the documents for training and 20% then for testing. So after we use the 80% of documents for training, we test the model with the remaining 20% of the documents, and as we also tag the documents in the test documents, the tags in the test documents, we can identify how good our model is working. The goal is to achieve more than 95%. This was our initial goal. We tested it first. We started with about 20 or 15 documents, which were documents we took from our knowledge center, which was on Confluence. With these documents, we tagged the services and trained the model, and we had a success from about, I think it was 25%. So it was really horrible bad. But this was because of the low number of trainings documents, and we started then to increase the number of tag documents, and now we are in about I think it's 200 or 300 documents which we tagged automatically, and I will explain this a little bit later how we did this. So we did not tag all the 300 documents manually, because we are only 2 people in the project, and it would be a lot of effort. We used the static recognition model of the Azure Search to identify the known services in the document. So we had a list of CSV file where all the services that are used in Androids are listed. And this CSV file we compared to the existing training documents, and this was possible to create the tagging document then automatically. So with that, we increased the success from 25 to 95%. So we got an approved model, and this improved model we deployed then, and this deployed model we can use now for classifying text text in the skill pipeline. So this was the approach we had here, was to move away from static tagging into automatic tagging, and this was really a very, very huge success because it took us only 2 or 3 hours to tag then 200 or 300 documents, and as soon as we got new content from other sources, we can use the same automatic tagging model for as well. I would switch over now to the demo. I think, yeah, exactly. This is the next. So I would show you live how the Language Studio is used and how we can use this then in the search. So can you please switch over to my screen? Yeah, thank you. Is my screen live now? Because I cannot see you anymore.
All good, all good.
Okay, great. So what we see here is the Microsoft Language Studio. The Language Studio is available at language.cognitive.azure.com, and you have to provision it into a cognitive services in Azure. So here we have our cognitive search, our cognitive service provisioned. We also have a cognitive search service here. The rest is only used for storing the documents and for the pipelines. So if we start the Language Studio, we first can create a new project, or we can create we can use an existing project. So we have here one document. You see there are different types of documents. We only will use today the custom named entity recognition projects. All the others might be interesting in the future, but today we are only focusing on custom named entity recognition. The first thing then was, I can show you how this looks like if we start a new project here. I can connect to my Azure resource. You see here we got our language, our cognitive search language resource, and we need a storage account where our documents are stored. Then I give them a document, a name, a description. I can define if it's a single language document, or if all documents are in one language, or if we want to have multiple language enabled. And then I can say where my documents, my training documents are stored in this Blob container, in the storage account in what Blob container. For example, here I can take this one. I do not start over here because I already did this. And the next screen would be that I get all my documents here in the left side here. So you see, I can select, for example, here a document, and all the documents are already tagged with the services. You see, we have additional entities also defined. These are not automatically detected. These are detected. These are tagged manually. So if I, for example, have identified another service here, I can mark this in the document and say, okay, this is a service. And you see after that it's marked as a service. After this is not done manually. This is the part that my static tagging did for me. We used a small C# program to get the tagged content out of the search index, to know where the different static information has been found in the documents, and then we translated it into a specific JSON format, which is documented on the Microsoft developer documentation page for cognitive for custom named entity recognition, and throughout that we were able to do this tagging automatically. After that, we went into a training job. So we started a training job. We defined how the new model should be named, how much % of the data we tagged should be used for training, how much should be used for testing. You can do this automatically, or you can do this manually. So this is a standard approach in artificial intelligence training, creating training sets. And after that, we get a model. It took us about, I think it was 2 or 3 hours, because we have a large number of documents until this model has been created. And you see we got a F1 score of 95.7%. And the F1 score is something which is built up of the 2 scores here, the precision and the recall core. The precision score is how good is the model in the recognition of or how many false positives do we have in the recognition of the test set, and the recall is how many false negative do we have in the test set. So this, you see that we have a very high precision in the service. So every entity have a specific precision and recall. We started. You have seen we have four entities in our model here, but we trained this model here only with 1 entity. So if we would retrain the model, there would be 3 other lines here, which would be not that good because we haven't tagged so much data in the documents right now. And we found that you need at least 100 or 200 documents that you got a precision and recall score about 90%. So after that, we can go to test our model. And how do we do that? We take the model and select the model here. And I just prepared one small article from the Microsoft homepage. It's about creating a SharePoint online site, which is a standard knowledge base article from Microsoft. And I would go over here and paste it in here to see how good the recognition would work on that. And run the test. And you see we have a quite good recognition here. We see that we have Microsoft 65 apps are not recognized, but email is recognized as a service. SharePoint is recognized as a service. You can show it as cards, then you see how big the confidence of the recognition is, and you see all the recognitions 100%. This is because it seems that we trained SharePoint as a service directly in a lot of documents, so it's very good recognized in there. But it shows you how that now you can fill in nearly every text that you find. It's not a static recognition anymore, like we do it with a word lookup. It's a dynamic AI model, so it's really done with a neural network. So even if you do not, if you have services in here which are not in the training in the training set, we have a very high probability that the document that the service is recognized in there. So after we have this model deployed, we can put it into our pipeline, and the pipeline, and this is the way how to include this into the Azure search is currently only possible via the web skill job. So I switch over to my Visual Studio. Visual Studio Code, and in Visual Studio Code I opened up the cognitive search which I showed you before. And in the cognitive search, I want to show you, first of all, I want to show you the Blob Container which we used for the training. For example, we have here the our Blob container with all the services in there. You see down here, we have all the services that we imported from Confluence. So this is exactly the data set that is used in here in that list. You see, this is the same list, and with the from these documents, we're using a skill set to index. The skill set is this one, and the skill set does different type of different things. The first thing is that we do not have the possibility in the Azure Search to access directly the indexer does not have the possibility to access Confluence directly. The indexer can only access Azure databases and storage accounts, and now in preview also SharePoint sites, but we cannot access directly the Confluence data. So what we did is every Confluence page has a page ID, and we are using these page IDs into, we're putting the page IDs into a database, and our indexer goes over this database and only gets the page ID. And the indexer then calls our skill set, and the skill set, the first skill is getting the content from Confluence with the page ID. So you see, we have as input, we have a page ID and the page title, and as output, we have the page content. We do this in two times. One is formatted, one is not formatted. So we have another call to the Web API skill, a second one here. This is implemented via Azure function. So we are calling here an Azure function, and the Azure function is using the Confluence API to get the documents out of Confluence and return it to the skill. With the information that we get from the skill, we have the possibility to do this custom entity lookup. This is not a dynamic AI skill. This is the static lookup, and the static lookup is just it's a JSON file where we just have all the services listed. And out of that,
so this is basically having just the structure, how we are organized as an IT. What are our services, what products are related, and what's the support team and so on behind. This is just a specific thing we have created here.
And just to see the output of this skill set, I will open up the documents that are returned in our index. Now we go to our index, and if I go on this document, for example, you see this is the outcome. This is what in the index is written. So you see, this is here we have the raw content, which is with the format. Then we have I think we have a small. The content view here, this is without the formatting information. So this we are using then for the entities, and you see in that text there are three types of services are detected: modern workplace, computer hardware and operating system, and intranet. This is found because, for example, the text SharePoint is found on offset 2181, and this means on the position here there will be SharePoint somewhere. You will find it over there somewhere. So this is the way how we extract it into the index, and our C# program is doing nothing more than just looking on this index and transform it into this JSON file that is used for the tagging of the documents. So we're using, just to summarize it, we are a little bit in a time. Just to summarize it, we're using static lookups in the skill set to train our dynamic model that then will be used in a second skill set where we can dynamically detect the services with AI support in every document that comes new into Confluence. Okay, I would say let's switch over to Bernd.
Thank you, Peter. Thank you for the demo and deep dive. So let's go back. So as we are running out of time, I would just hold back some slides and proceed with the most important one. Maybe as you explained already, Peter, and maybe you want to proceed here. The main difference between a rather static custom entity lookup and a custom named entity recognition model. This is the difference basically, right, showed. Maybe you want to summarize the main difference again.
The main difference are that we have the custom named entity recognition model is great, but it needs to be trained. So if you want to have a quick success, start with the custom entity lookup. It's just a fuzzy lookup. It's a fuzzy lookup, so it can work with some failures in the model, but it's not an AI model. If you want to have a really powerful model that detects also new document information, then switch over to the custom named entity recognition, because this is an AI-driven model, and it needs to be pre-trained.
Thank you. So now let me go back one slide. Maybe referring back to the use case I explained at the very beginning. So why are we doing all this? And one of the use cases was we want to communicate with users in a natural language. Right, so we want to enable our apps to be able to speak language and understand language. And this is basically why we are now following this big picture, which is on the one hand where Peter was in now and explained, enable our search pipeline to understand specific entities. In that case, it's IT services, IT products, but also intents in content by using custom entity lookup or even by training a named entity recognition model. On the other hand, so the search model, so to speak, or the Android-specific model is able to understand Android's entities and intents in any content. On the other hand, we are trying to train a conversational language understanding model to enable a bot understanding the same language, the same entities, the same intents. And that's something in the making, to be honest. The target is that we can connect those two worlds, so to speak, that whatever a user is pasting to asking the bot is on the one hand able to understand and identify entities and intents, and has the same equivalent on the content side, because content or search also understands the same entities and intents. This is, so to speak, the big picture where we are trying to head to.
To step in here, currently we are focused on the entities, so the green one over here. But the next thing would be that we understand what the user wants to do with the entity, and this means to understand the intent. And this might be some further session in the future that we talk about how we recognize the intent of a chatbot.
Absolutely. So let's see where we end up. Just maybe spend the last minute on the general learnings. So as you have seen that when it comes to entity recognition and identifying enterprise context, the built-in skills are not so specific enough. That's maybe by nature, because enterprises have specific patterns for all those entities, and you need proper measures and tools and train them to get them back. Right? The web API skill, as Peter showed, is the tool, so to speak, to connect your pipeline, your search pipeline, to any external model or API to get the skills back into the whole skill chain. What you've also seen on Peter's screen, the VS Code plugin is really nice to work with. And this is, I think, all we can share for today. So thank you for joining our session. If you're interested and if you have questions, let's meet again in the Q&A stage, in these Q&A sessions for stage 4. See you then. Bye-bye.
Yeah, bye-bye.
Thank you, Peter.